Everyone, welcome to my channel. Today we will solve this problem. The problem says 27 to the power of m plus 9 to the power of m, which is equal to 150. Now we are asked to find the value of m. M is our required variable. So let's start solution. We can write the given equation like let's say 27 to the power of m plus 9 to the power of m, which is equal to 150 is our given equation. So 27 and 9 must be expressed with their least prime factorization method. So we can write 27 like 3 to the power of 3. Why? Because 3 times 3 times 3 gives us 27. The whole power of m plus 9 is expressed as 3 times 3 times 3. So 3 squared, the whole power of m, which is equal to 150. But we always remember that a to the power of m, the whole power of n is always expressed as a to the power of n, which is equal to a to the power of m, the whole power of n. So because of this rule, that means we interchange the place of m and n. So we can apply this exponent rule from here. That means 3 to the power of m, the whole power of 3 plus, 3 to the power of m, the whole power of what? 2, which is equal to 150. This is the second step. In order to find the value of m, we must replace 3 to the power of m with another variable. Let's say, let's here 3 to the power of m, which is equal to y. So now we need to replace 3 to the power of m from 3 here end. So we can write here again. So the equation becomes 3 to the power of m, the whole power of 3 plus 3 to the power of 2 the whole, the power of m, the whole power of 2, which is equal to 150. Great. Now we replace 3 to the power of m with y. Now y cubed plus, here we have y squared, which is equal to 150. Then again, we subtract on both sides of the equation 150. So we subtract here 150 and we subtract here 150. On the right, we have but 0 here. That means this is cancelled out by here 0. Then y cubed plus y squared. Y cubed plus y squared minus 150, which is equal to, one perfect cube and one perfect square. That means 125 plus what? 25. So we replace this with y cubed plus y squared. 150 is expressed as 125, minus 25, which is equal to 0. But 125 and 25 can be expressed in terms of what? Their least prime factorization. That means y cubed, plus y squared minus 125 is 5 times 5 times 5. So 125 is multiple of 5. So now 5 cubed, here is 25 minus 25 is expressed as 5 squared, which is equal to 0. We can group the highest degree with highest degree and the least degree with least degree. That means we can here y cubed here and also 25 here. Then y cubed minus 5 cubed plus y squared, minus what? 5 cubed, which is equal to 0. 3 the power of m is y. This is our initial point. But here we have here y cubed minus 5 cubed plus y squared minus 5 squared, which is equal to 0. We can group here and here again. Thus we always remember that a the power of 3 minus b the power of 3 is always expressed as this is equal to a minus b, a minus b in bracket a square plus ab plus b square. A cubed minus b cubed is always expressed as a minus b. then multiplied by a square plus ab plus b square, and also a square minus b square is always expressed as a square minus b square is always equal to a minus b times a plus b. Now we can apply this to factorization methods on the given expression. So y cubed minus 5 cubed is expressed as, we can apply this from here. That means I apply this for here, and also y cubed minus 5 square for this. Now we can express this equation like this. Then y cubed, yes, y cubed minus 5 cubed is expressed as y minus 5, yes, times, yes, y square. Why? Because here y is a and negative 5 is a, equivalent with b. Then y square plus 5y plus 5 squared, that means 25. Then again plus y minus 5 again times what? Y plus 5, which is plus 5, yes, which is equal to 0 here. Then again we can factorize y minus 5. We have the common factor y minus 5 here, and also y minus 5 here. So we can take it as a common factor y minus 5, close the bracket. Yes, we left here only what? y square plus 5y, yes, plus 25. And also we have y plus 5 here, y plus 5 here. Then we close open bracket, which is equal to, yes, here is 0. Y minus 5, yes, the whole squared, close the bracket. We have 5y plus y, we have 6y, then y squared plus 6y, and also 25 plus 5 is, we get 6y plus 30, yes, which is equal to 0. Great. Now we have what? Two solutions. That means one is written in the form of quadratic, but the other is in the form of linear. So y minus 5, which is equal to 0, is the first solution, or y square plus 6y plus 30, which is equal to 0. Then from the first we have y, which is equal to 5, is the first solution, but here we must check b square minus 4ac must be greater or equal to 0. That means we have b 6 and a is 1, c is what? 30. So if we get b square minus 4ac is less than 0, this expression has not a real what? Solutions. So we can check it, 6 square minus 4, but here the value, the coefficient of y square is 1 times 1, c is 30, great, less than 0. That means 36 minus 4 times 30 is 100 what? Yes, 120 is less than 0. So 36 minus 20, we have got a negative number, so this is true. So this quadratic equation has not a real value on the real number system, but we can get a value, that means a solution set of y with complex numbers. But here we must take the value of y with real solutions. So the only solution is y, which is equal to 5. So now initially we have 3 to the power of m, which is equal to what? Y. So here the value of y is 5. So we can replace what? 3 to the power of m, which is equal to 5. In order to find the value of m, this equation is what? Written in the form of exponential function. So we can change it into what? Its inverse, that means log. So we always remember that a to the power of b, which is equal to what? Y. If and only if, this is if expressed as what? a log of, yes, log of a log of y to base a is, which is equal to b. So our we can apply this rule on here. We have what, base b, and this m is becomes m, which is equal to log of what, our base is 3. That means log of 5 to base 3. This is what the solution set of what, m. So when we substitute log of 5 to base 3 here, we can directly get what, 150.